This is a little bit more of a lesson 11. It's basic rules of differentiation. It's part 2 of it. I got cut off in the fun problems. Let's go back to 94 again. It's probably maybe where it cut me off at. All right, so we're working on finding the average rate of change. The average rate of change is on the original function f of x over the function over a given interval. And when they say a given interval, they mean an x interval. So they mean from x being 0 to x being pi over 6. So that's the given interval. Compare the average rate of change with the instantaneous rate of change. That would be the derivative at an actual point in time on the curve. So looking at the graph here, I'm going to put it back in again. So y equals sine x, and then on your zoom you want to go down to trig number 7, and it makes a nice picture of the sine wave. That's the basic sine wave. And they want to know about between it being x equals 0 and x being pi over 6 or 30 degrees. This would be 90 degrees there, the first tick mark. That's pi. And over here is 3 pi over 2 and 2 pi. So here's one full wave of sine. Anyway, they want to know the average rate of change between 0 and 30 degrees. So that little piece of the line right here. Now, again, it's not a line. And so the slope isn't the same if you pick any 2 points on the curve because it's not a line. It changes as it goes up and down across that little area. So when we find the rate between these two numbers, it's going to be a line. We're going to be making a line between those 2 points. And that'll be different than the instantaneous rate at just the number 0 and pi over 2. So again, you want to start off here by finding for the average rate of change. Again, that is just slope. When they say rate of change, they mean slope. Remember, slope is the change in y over the change in x. Here, our change in x is 0 to pi over 6, so I'll go pi over 6 minus 0, using that slope formula, x2 minus x1 and y2 minus y1. And then on the top here, you're going to do f of x, or where the y is at. So to get the y, you have to plug it back in for that x value. So f of pi over 6 minus f of 0. So pi over 6 minus 0 is pi over 6. And then this is where it really comes in handy that you memorize your unit circle. You really need to know these from the top of your head. So when you plug in 30 degrees for sine here, the sine of pi over 6 or the sine of 30 degrees is 1/2. And then put 0 in for x, so the sine of 0 is 0. So that gives you 1/2 divided by the pi over 6. And cleaning that up, you don't want to have a fraction over a fraction, so I'm going to flip the bottom one over and multiply the denominator and the numerator by 6 over pi, so it's 1 on the bottom. And then on the top you get 6 over 2 pi when you multiply straight across. When you multiply fractions, you multiply straight across. 1 times 6, 6, 2 times pi, 2 pi. And then so 6 divided by 2 pi divided by 1. So anything divided by 1 is just what it is. So it cleaned it up to be 6 over 2 pi or 3 over pi. That is the exact answer. That's exact, 3 over pi. If you divide 3 by pi on your calculator, you get about 0.866. That's approximate. We rounded it. We truncated off the answer. It's an irrational number that goes on forever. So you have to cut it off, and that's what makes it approximate. Okay, so that's the average rate of change using the original f function between 2 points on the curve, which is going to be different. It's not going to be the same slope as at those 2 points because, again, it's a curve and it's got a different slope at all the different points. So if we want to do the instantaneous slope, we have to take the derivative because the derivative is at any point on the curve. So again, the derivative of sine is cosine. And then if you want to know the instantaneous slope at cosine of the endpoints, which were 0 and pi over 6, we're going to plug that into the derivative. So cosine of 0 is 1. And then the cosine of radical 3 over pi over 6 is radical 3 over 2, which is about 0.866. Okay, so if you wanted to talk about how the average rate of change compares to the instantaneous rate of change, you can see that the average rate of change is in between those two numbers. So again, the big takeaway from this is when they want the average rate of change, it's on the original function. Find the slope of the original function using the two endpoints. Instantaneous rate of change is using the derivative. You have to take the derivative. And then you plug in the endpoints and find out what those two numbers are. Next up, we're going to talk about velocity. So on the next page here on velocity, let's see. Let me find what the word is for it. It's the velocity function. The velocity function you get from the position function, s of t. So s, it's an s, not a 5. So s of t is the position function for an object moving along a straight line. And then the velocity is when you take the derivative of the position function. So they're doing the definition here of how to find the derivative, which again is the limit is the time approaches 0, or the distance between the 2 points approaches 0, the limit of it at that one point in time on the curve. And again, that's just the derivative. So the velocity function is the derivative of the position function, or we call that v of t. This formula down here is for a free falling object negating air resistance under the influence of gravity. It says s of t, the position of an object, is negative 1/2 g t squared plus v sub 0 t plus s sub 0, where g is gravity, and if we're talking about gravity and with feet, it's 32 feet per second approximately. If we're talking in meters, it's approximately 9.8 meters per second. All right, so let's do a story problem. I know you're excited. Woo, story problem, stretch it out. You can do this. It says, a ball is thrown down straight from the top of a 220-foot building. So it's starting for its initial position, s sub 0, is 220 feet, with an initial velocity. So when we threw it, we flew it at a velocity of negative 22 feet per second. What is the velocity after 3 seconds? So the time equal to 3. And then what is the velocity after falling 108 feet? All right, so s of t, again it's an s, the letter s, not a 5. S of t is equal to negative 1/2 times gravity, and our gravity here was in feet, so we're going to use the 32. And then times t squared, I'll move this down, so times the time squared then, and then plus the original velocity, which is negative 22, and then plus the original position of the object, which was 220. And so that cleaned up is negative 16t squared minus 22t plus 220. So the velocity of it, s sub t, which is the velocity, take the derivative of it, is negative 32t minus 22. So that's the velocity function. And then what is its time at 3 seconds? So you got to plug in the 3, so do v of 3. So negative 32 times 3 minus 22. And you get negative 118 feet per second. So after 3 seconds, it went from the height at 220 feet down to 118 or 112 feet. And then this question is different. This is different than the other one. So don't get confused. When it says, what is the velocity after falling 108 feet? That's a new question. It's all new. So what after 108 feet? Well, we need to see how long did that take? What is the time it took to go 108 feet? So that's the original position function. So s of t is equal to, again, negative 16t squared minus 22 plus 108. We want to know what is the velocity after falling 108 feet. So, so I put 108 in for the position function s sub 0. So instead of starting at 220, it's where is it at when it's at 108. And if you solve that equation for 0 then to find out what the time is, doing, you could do, you could factor it or do the quadratic formula. You'll get that the time is equal to 2. So then you want to do the velocity at 2 seconds. So that would make it negative 32 times 2 minus 22 are negative 86 feet per second. All right, last one. We got one more of these, which you really do need to watch. All right, so the last one here says a rock is dropped from the edge of a cliff, which is 214 feet above the water. So that would be S sub 0. And they drop it. So they didn't throw it, they dropped it. So that makes the initial velocity, this is the thing I wanted you to know, that makes the initial velocity 0. It wasn't thrown with any effort at all, they just dropped it. So there was no velocity involved. Determine the position and velocity function. So the position function of it, S of t, again is negative 1/2 gt squared plus v sub 0 t plus s sub 0. This was in meters. So since it's in meters, we need to use for the gravity number 9.8. The velocity was 0 and our initial height was 214 feet. So when you clean that up just a little bit, negative 1/2 times 9.8 is negative 4.9 t squared, and then plus 214. So that is the initial position function. And then the initial velocity, when you take the derivative of the position function, 2 times negative 4.9 is negative 9.8 t squared, and the derivative of 214 is just 0. So that's gone. Okay, so that's letter A. This is the position function that I wrote over and crossed out. This is the velocity function. And then on B, it wants to know the average velocity. Oh my heavens, remember on B here, they want to know the average velocity for the interval 2 to 5 seconds. So that's going back to the original function. And the original function, again, S of t was equal to negative 4.9 t squared plus 214. So we want to find the slope for that x interval from 2 to 5. So the original function, S of t, we want to know what the slope it is from the number 2 to 5. So again, it's the change in y over the change in x. And our change in x here is from 5 to 2. And then we want to do S of 5 and S of 2. So 5 minus 2 is 3, and then S of 5, if you put the number 5 in here and find the number for it, you're going to get 91.5 minus S of 2, put 2 in there. So put 2 in there, I'll just do that one. Negative 4.9 times 2 squared plus 214, and you get 194.4. All right, so subtract and divide, and you're going to get negative 34.3 meters per second, which is going to be different here for the next one. On letter C, they want to know the instantaneous velocity at the time equal to 2 and 5. Instantaneous, so again, this is the original function, which is S of t. The new one, instantaneous velocity, you have to use the derivative of it, which is the velocity when you take the derivative of the position. So we're going to use the velocity function here on C, which was negative 9.8 t squared. So the instantaneous number at time equal to 2 and time equal to 5 would be v of 2 and v of 5. So if you put a 2 in here, 2 squared times negative 9.8, and you're going to get negative 19.6 meters per second. If you put in the 5 into that function, you're going to get 49 meters per second. And I just remembered, I just noticed, I think I made a mistake. Son of a gun. Way back at the top. Wow. This is horrible of me. So when I took the derivative of it, it was negative 9.8 t to the first. Oh my heavens. Just hate me. So down here, this should have been to the first also. That's to the first. So then you get those two numbers. Those are the numbers you get. I'm so sorry about that. All right, and then D, it says, find the time required for the rock to reach the surface area of the water. Well, the surface of the water, this was one I wanted you to know. This is important. When it hits the surface of the water, that means the height's equal to 0. Height is 0 when it hits the ground. If you drop it, the velocity is 0. If it hits the ground, the height is 0. Need to know that. So letter D, how long until it hits the ground? Well, that's when the height of the original position function, s of t, is equal to 0. So that's what you need to do, set the original function, which was negative 4.9 t squared plus 214 equal to 0, and then you solve it. So you get t squared equals 214 divided by that 4.9. And you're going to get two numbers, a negative and a positive. Obviously, you just want the positive number. Time's not negative. So it's going to take 6.61 seconds for it to hit the water, to hit the ground. And last of all, what is its velocity at impact? So that would be the instantaneous velocity of when it hits. So we want to do v of t at, v of t at 6.61. That's why they had you do that on letter D. You need to know that number to do E. So doing v of 6.61, plugging it in there. Again, it was negative 9.8 t, not t squared. Again, sorry about that. So plug in the time. So it is 6.61. And when you multiply them together, you get negative 64.8 meters per second. All right. Thanks a lot. I'll see you for the next lesson.